Hello and welcome to another coding session. So today is what? Today I think is Saturday, the day of the Saturn, and that means today, according to the schedule, we are doing a game development in C++ with Opengl. How about that? Bet you didn't expect that shit to happen. So the game is completely open source. It doesn't have a name at all. So the name is a secret. It looks like this. But it's not a final look and feel. The game is not finished, so it's more of a technological demo. So we are just developing this entire thing. You know, we're developing our own engine. And you can find the source code in here. The source code is available for free for everyone, forever. Yes. Source code. There we go. So we can find this shit in here. Okay, so, and what I'm planning to do today, I plan to actually add support for text finally. I learned enough Opengl and how to work with textures in Opengl to actually implement a simple bitmap font rendering. By the way, I did that also on a programming session, so I think you can find the video where I learned about textures on this YouTube channel. So let me see, make it part of a game. How to work with Opengl textures. Yeah. So this is precisely what it is. If you also want to learn about how to work with Opengl textures, you may want to take a look at that specific code because we went through tutorials. How to work with Opengl textures, and the knowledge we gained in that video is going to be useful today because we are going to apply it. So essentially I'm going to use this font created by Awesome Domson. So you can find more of his fonts on the Open Game Art website. Let me actually quickly find his profile. So let me see. So yeah. So we're gonna use one of these fonts. Yet again, I'm using them in all of my games because they're so easy to use. I just don't want to deal with like free type thingy and like proper fonts and stuff like that. So I usually quite often use them as a placeholder. And also the game is actually quite simple enough, so I don't really need like a proper pretty font rendering. Maybe at some point we'll need to do that, but for now, as a placeholder, I'm going to use this simple bitmap font. So let me put the Domson profile in the description, right? Bitmap fonts, right, there we go. So you can find all of that in the description. Everything I put in this little file goes into the description. So if you open the description box, you will see all of the links are there. So that's why this file is called description.md. MD stands for Markdown. Yes, I'm using Markdown for some reason, even though YouTube doesn't support Markdown. I wonder why though. Probably because people will start to abuse it. Yeah. So every small little feature that YouTube has will be and should be abused to hell. Yes. Because of the sheer size of the platform. The platform is very, very huge. Alrighty. So let's go. So what we're gonna do first, I think I'm gonna actually take this font. Right, is this a cell phone? I'm not sure if I want to use cell phone, but maybe it doesn't really matter that much, right? Because once we implement the renderer for this font, we can substitute it. With any of these fonts because they more or less like follow the same conventions. So I'm gonna put this entire thing into the textures. All right, so let me actually move it in there, and maybe we're gonna create some sort of a class or abstraction for the font, right? So let's create something like I really like how I said something and then I literally typed something, and it's called something because it's a code name of the game. It doesn't have any name yet, or it's a secret. I can neither confirm nor deny if there is a name for this thing. So let's call it a font. So it's going to be HPP, and let's do it like this. Something font HPP, and we're also going to define it, and this is going to be end if. There we go, and it's going to be just simply a structure. It's going to be just called a font, simply a font. So I think the first thing we're going to do, we're going to actually load the font into Opengl texture. So I'm pretty sure we already have an abstraction for the Opengl textures and whatnot. So you can already just load the texture from the memory, right? And then you can construct a GL texture out of it. As far as I know, you cannot customize some of the parameters of this texture. Specifically, you cannot customize the filtering and stuff like that. So all of that is hard-coded for the texture atlas. And maybe one of the things we're going to do in here, we're going to actually unhard-code some of these things. So yeah, let me actually include a texture. So this is going to be just a texture in here, and maybe it's also going to be GL texture. There we go, GL texture. I'm not even sure how to call that. Should I call it GL texture? Maybe. So we have a similar abstraction called atlas, right? And it, yeah, it literally has like texture and GL texture. Okay, cool. Texture and GL texture. So I suppose we're going to have something like init, and let's call it like load from file, like load from file, and it's going to take the file path, right? So we're going to be loading a font from a file. Something font CPP. Let's create a CPP file. Include something font HPP, and let's actually implement this function. So this function is going to be something like font load from file, and what we're going to do in here, I suppose, I'm going to essentially just call load from file from the texture. So I'm going to actually pass it to here. So we have a save to PNG file. It's not the right function. It's called from file. Oh shit, this one is actually yeah, it initializes it like that. Okay, that's totally fine. So it's going to be something like texture from file, and it's going to be file path. There we go. We initialize this entire thing. Cool. So what else do we need in here? We also probably want to create GL texture, right? This one is going to be GL texture from texture, and there we go. And that should be enough. That should be enough. So another things that we'll need to do in here. Oh, and yeah, so the textures also have different texture units and whatnot. So this one is going to be very interesting to implement. Different texture units. Oh boy, oh boy. All right. So let me go to the main thingy, and where do we have an atlas? Where do we construct an atlas? I don't see. I think we're constructing an atlas inside of the game. Yeah, we do. Okay, that makes sense. So we initialize the game with the window, and we create an atlas, and so on and so forth. I suppose it does make sense to actually keep the font inside of the game. So this one is going to be something like font, right? And in here I'm going to be including something font HPP. There we go. Here's something font HPP. And in initialization, somewhere near the atlas. So because atlas and the font are kind of similar things, because atlas is also a texture, and yeah, so they're really similar entity. That's why I want to sort of like feel like I need to group them together. So well, to be fair, this one is actually, so we have two conventions, like init convention and from convention. Init convention takes sort of zero initialized structure and initializes it, and from convention returns the structure fully initialized. So I'm not sure which convention to follow in here. I constantly switch between them for some reason. To be fair, maybe for the font I'm gonna also follow the from convention. So from, yeah, let's call it from file. Yeah, let's also call it from file, and yeah, this one is gonna be from file, and because of that this one is going to be static and it's going to return a font, and here we're also going to return a font, and this one is going to be basically the result. We're going to zero initialize it like this. Instead of this we're going to be using result. Right, so this one is going to be result, and we're going to return result like this, So yeah, we just have a from pattern in here. So here's the font, and then we're going to have font from file, right? And it's going to be assets, textures. And do we have anything? Okay, so Emacs is incapable of auto-completing files from this path, which is fine. I can just do that myself. Thank you very much. And let's try to compile this entire thing and see if it's going to work or not. Okay, so I'm pretty sure it's not going to work because we didn't add the font file into the build. So we're using single compilation unit thingy, where basically you take all of the CPP files and include them into a single CPP file, and you just compile a single CPP file as a single compilation unit. So I wonder if there is still a page on Wikipedia about this thing, single compilation unit, because I think it was suggested to delete. No, look at that, there's still a thing about that on Wikipedia. So but it's still sort of like Wikipedia thinks that this article is sus because it doesn't have enough citations. Is that how we pronounce it, citation? I'm not sure. I don't speak English, I'm sorry. I need to check the dictionary. Citation. I'm pretty sure that's how you pronounce it, because it's an open syllable and stuff like that. So I can already see it's citation.
Citation.
That's pretty loud. But yeah, I was right. Thank you very much. Sorry, I don't speak English. I don't speak English at all. So description. Single compilation unit. Single compilation unit. So, and since we're using this kind of approach, we need to include that font CPP in here, and it will be automatically built. Hopefully. So as you can see, it issues one compilation command, and of course it didn't work because there are some mistakes in here which we can easily fix. No biggie at all. So here's the texture. This one has to be a result texture, of course. And there we go. We managed to compile that. Though a single compilation unit might be might take a lot of time, or like a long time to build a release. It might take a lot of time to build a release. But to be fair, if we actually compiled all of that separately, I'm not sure if it would take like less time. But I mean, in incremental builds it probably will take less time, but incremental builds have a tendency to quite often break, so full recompilation always never breaks. So so here is the release build, but it's all of that is with all of the optimizations enabled, right? All of the optimizations enabled. So without the release, it's going to build a little bit faster. And it's already done. Oh, this is not how you execute this entire... And something got completely broken, and I do understand why. Yeah, I do understand why, because the texture unit got replaced by the font, and you can clearly see that. So this is like a parts of the font sprite sheet. This is actually quite cool, right? So if you take a look at the texture, so char map, yeah, here it is. So it's basically this texture picking in the entities and stuff like that. So to fix that, I think we need to actually bind all of this like JL texture to different texture units, right? So let me see what we can do in this particular case. Let me find a texture CPP. Right, and I wonder how we're going to specify that. Maybe we're going to specify the texture unit in here. So let me see. It's not a package. GL active texture. So it's a GL enum, GL enum unit. let's call it texture unit. I mean, we are in the context of a texture, so it should be clear what exactly do we mean. Yeah, and you usually want to do that before you bind anything, as far as I can tell. Maybe even here, active texture, and we're going to put a unit in here. And if I go to here, right, gel in num unit, and let's try to recompile this entire thing and go through the compilation errors and fix all of them. So here I have to provide the units. So here we're loading the atlas. Okay, so for the atlas we're gonna have gel texture 0 unit, right? So this is gonna be that. For the font, we're going to have gel texture 0 + 1 unit, right? So we're gonna hardcode these things for the time being, and hopefully after that this is going to be fixed. Yeah, there we go, we fixed it. Beautiful. But for some reason I see tearing and stuff like that, and I'm not sure what causes the tearing. Even though I configured my machine to like not have tearing or anything like that, but I don't know. So yeah, so and that's pretty much it. So we fixed the problem, and I learned about texture units in the tutorial that we read in this video, right? Actually, this video, right? So check it out in the description. So we learned about texture units in here. In the video how to work with Opengl textures. It was really educational, actually. I really enjoyed it. Okay, so let me create a separate branch. I wonder if I have a like an issue for fonts, for text actually. Text. I don't think I have. Game does not indicate the vars config file loading. Well, I mean, this is kind of related to the text because we're going to be using text to indicate the failed config loading or something like that, but apart from that, we don't really have an issue for that. Okay, so text support. So we're gonna just have this kind of thing. Introduce font entity, right? And I'm gonna push that right into the repo. I'm gonna push that right into the repo. And I wonder how we're going to render all of that, because when we're rendering everything, all of our programs actually expect to all of our programs expect to work with Atlas, right? So by programs I mean shader programs, right? So here are shaders, and in here I think we have to go into the fragment. Yeah. So we have an Atlas, and Atlas is set to 0. So to render the text, now we need to switch that sampler to D to a different one, and I'm thinking we probably need to create a separate program for that. That's for sure. We need to create a separate program for that. But what kind of program it will be? What kind of program it will be? It's a good question. It's a good question. And well, to be fair, for the fragment shaders and shit, we will only need a different fragment program. But what about Vertex program? So we have a Vertex program here. So the problem with this rect thingy is that it works inside of the world coordinates. But what we want to be able to do, we want to be able to render text both in world coordinates and screen coordinates. That's what's interesting about all of that. So I have an interesting idea. What if we actually split? Somebody is splitting IRL. I hope it's not going to be too loud on the recording, so I really apologize for this kind of stuff. Welcome to Mother Russia. Opa! So anyway, basically I have a rect vert which is in the world coordinates. Maybe I'm gonna create a separate one that basically doesn't have this camera projection thingy and ignores all of the camera nonsense. And basically, if I want to render text, I'm going to be like on the screen, I'm going to be using the screen coordinate shader program. And if I need to render the text inside of the world, I'm going to be using the world program, and I'm going to be switching between them and stuff like that. Because rendering the text is just like, yeah, it's essentially drawing a quad and then texturing the quad with the corresponding UV coordinates. So all of the shader programs to do that, like I already have them, right? It's just like, I need to like do them. I need to like slightly tweak them. So because, for example, this thing could be definitely reused for drawing the text. Why not? I don't see any problems in that. So, but then this is not an atlas anymore. It has to be called something like, I wish I could call it a texture, but texture is already taken a word. So maybe it's going to be some sort of an image, right? So it's some sort of an image. And I wonder how difficult it is to rename a uniform in our source code, because we take that name in a C++ code and bind it and stuff like that. And will changing the name of this variable break everything and tell me all of the places I have to fix? I don't know. We'll have to see. We'll have to see that. All right, so let me try to recompile this entire thing and see how miserably it will fail. Okay, so I mean, of course, it's not a compilation time error. Okay, so it was fine. I'm actually quite surprised that it's fine. Even though I just like renamed a thing in here, and it was totally fine. So we have a fragment of an image. Oh, I know why. This is because we actually never set it. Right, because we just use a default value of 0, right, and default value and 0 unit is the first texture, right? And okay, so that's totally fine. And I suppose in HSL we would be able to do like a similar thing. We can rename atlas to image, and it's gonna work fine. So apparently, like for that specific case, it was super easy to rename this thing. So whatever. So, and let me try to run this entire thing, and everything seems to be working. Even HSL seems to be working. So let's do a committee. Excuse me. Rename atlas to image in shaders. Right, I'm gonna push that right into the repo. Yeah. So I kind of want to rename some of my shaders, right? So this is the, why do I call it rect? This is not a rect anymore. So this pair, like these shaders are more concerned about like texturing, right? So it would be better to give it a name. So what this thing does, it takes an image, position and UV coordinates, and basically textures the thing. So it would be better to actually call it appropriately, if you know what I mean. It's not just rect frag. So it would be better maybe to call it like UV color. Maybe UV color. So a simple a fragment shader that textures the fragment with according to the provided image and UV coordinates and multiplies it by the color, right? So that's basically what it does, and you can reuse these fragment shaders with any other vertex shader that you want, right? So yeah, so it's just like, it's highly reusable. It's a very highly reusable thing. It just accepts a color, UV coordinates, and it just like, and also an image, and just combines everything together. So it doesn't even need time as far as you can tell, right? So time is like literally not used in here, so whatever. So it only needs image, color, UV, and output color is going to be just that. It's a very simple one. So so maybe texture plus color. I don't know, is that a good name? Texture color, right? So it's a texture color, a fragment shader that textures the fragment according to the provided image and UV coordinates and multiplies it by the color. Okay, so that's what it is. So this is the rectangle thingy. Well, what this thing does, it basically lets you draw a textured triangle, right? So you provide positions, color, UV, and then it's all passed further, and it could be passed into the texture color, right? So maybe this thing should be also called in a particular way. So I think it should be called something like triangle, like maybe like a basic triangle, right? Basic triangle. Vertex shader that renders a triangle with a particular UV coordinates and color. Yeah, I'm really sorry if I make typos. I'm really sorry if I make typos, because like it's kind of, my brain works in a really weird way, so I really apologize if I make typos. Vertex shader that renders a triangle with a particular UV coordinates and color, right? So you provide position, color, and this one is actually interesting. I think it shouldn't be actually called basic triangle. I think it should be called triangle world, because one of the things this fragment shader does, it also applies the camera projection. Right, so it's inside of the world, but maybe camera, triangle camera, right? So vertex shader that renders a triangle with a particular coordinate and color with applied camera projection. To be fair, like if you don't want to apply a camera projection, maybe you just set the camera position to 0, 0 and camera zoom to 1, and there you go. Right, so basically if it's a 0, 0, it's going to be just 2 position, 1 divided by 0. Yeah, it's going to be basically a screen. So yeah, maybe we don't need a separate shader for drawing triangles on the screen. You just use the same program, you just like set camera position and zoom to 0. I think it's fine. Isn't that how Unity does that? I never actually used Unity. But I heard that UI elements in Unity are drawn in the world. You just set the camera to like 0, 0 or something like that. Like with the orthogonal projection or whatever. I'm not a game developer. I know nothing about game engines and shit like that. Sorry. But I think like I heard it's roughly how it works. So here's the triangle camera. So we also have a texture color. Right. So particle. Particle is an interesting one, I would say. So this is a fragment shader. This is a shader that generates a texture for our particle. Right. So if you open the game and something is completely broken, yay, yay. Oh yeah, so now we have a situation that we don't have these files. Yeah, we renamed all these files. Now we don't have them anymore. Okay, so let me see how they were renamed. So rectfrag became something like texture color, if I understand correctly, right? So it became texture color. This one became triangle camera, right? If I understand correctly. And maybe the corresponding enumerations should be also renamed to that, right? So it's going to be texture color frag shader. Yeah, it should be probably renamed somewhere in the renderer. Renderer HPP texture color frag shader asset. This one is going to be triangle camera vert shader. And also let's update it in here. But I mean, I can just try to recompile that and see how it goes. Okay, so I need to do something like build and then run it yet one more time. Okay, texture color, right. This one is triangle camera. So there is another places in here. So here is the regular program, and it's essentially using triangle camera vertex shader plus texture color fragment shader. So yeah, it's actually pretty straightforward. Regular program is just like you render a triangle. Oh my, it doesn't know how to. Oh my. Yeah, A-style don't know how to format this. Like it just doesn't know how to format this. It's so sad. Yeah, so regular program is basically a combination of triangle camera, a vertex shader, and texture color fragment shader. Okay. So is it going to work? Well, and we also just reuse a triangle camera vertex shader, and this one is also a triangle camera vertex shader. Okay. So a program is a combination of different vertex shaders and fragment shaders. All right, so we just reuse them. All right, is it gonna work? It is working, yay! Okay, so here's the particles. We have these blobs, and the texture for that blob is generated by a fragment shader, and that fragment shader is called particle frag. Right, so we have so promoted 3 constants. I don't know what it's talking about, but yeah. Anyway, so this is basically what this fragment shader does, right? It generates the texture for this thing. So we need to come up with a good name for this thing. How is it going to be called? Maybe gradient circle. I think that's a pretty good name for this shader. So this one is going to be gradient circle, right? So a fragment shader that generates a texture for a gradient circle with a given color. Right, that's basically what it is. It's a gradient circle. So we're slowly building up our engine with like different shaders and whatnot. I really like that. It's actually pretty cool. So and in here we're gonna have something like this. So gradient circle. Right. So here's a gradient circle. So there's a couple of places where we need to do that. Gradient circle. And particle program is a triangle camera vertex shader plus gradient circle fragment shader. Okay, I really like that. I'm really glad that I decided to rename these programs, the shaders, because now all of that makes more sense. Right, in all of the cases we just use the triangle camera vertex shader, but different fragment shaders to achieve different like looks and feel. Right, so interestingly enough, there's not that many. There's only one single vertex shader. We're using the one single vertex shader. So maybe at some point we'll create like separate folders for fragment and vertex shaders. So because when they're all like mashed up in here, it's kind of difficult to deal with all of that. But maybe I don't know. We'll see. Maybe it doesn't really matter that much. So HSL is just generates this rainbow animation, right? So I wonder if I wanna, yeah. Something went wrong. This is probably because I actually run the program from a different place. Is that the reason? Doesn't even say anything. No such. Oh, because yeah, because I renamed it. Okay. Yeah, when this kind of stuff is handled at runtime, it's just like kind of a little bit difficult. So particle is a gradient circle. Yeah, circle. There we go. It is in fact a gradient circle, and let's try to recompile this entire thing. Something debug. All right, noisy. Okay. And here's the interesting thing. So what are we going to be using for the font? To be fair, for the font, we need triangle camera, right? And if you want to render it on a screen, you just set camera position to 0, 0 and the zoom to 1. That's fine. And a texture color, right? But in case of the font, we'll just have to replace the image, this image, with the image of the font sprite sheet, right? So, and it should be as easy as just switching it to 1, because right now it's 0 because it's default value, but the texture of the font is located on the texture unit 1, so we need a way from our game to set this thing to 1 somehow. I don't think we have an easy way to do that right now, but maybe at some point we will. Let me commit. We did a little bit of refactoring in here, like renamed some shaders and whatnot. Maybe we're also going to put them in separate folders. I kind of feel like I want to put them in separate folders for some reason. So maybe we're going to have something like vert, right? And just, yeah. And then frag, right? So here's the frag. There we go. So we have shaders. Here are all of the fragment shaders. Here are all of the vertex shader. We use only one vertex shader. Maybe in the future we're going to use more of them. Maybe for some different effects that modify the positions of the vertices, right? Maybe there will be some special shader that sort of like makes the vertices wobble to create some sort of interesting effect and whatnot. Maybe for some like a water effect, or we'll see. So, but for now, I don't think we need any other vertex shaders, so this one is perfectly fine. It's very versatile, right? It supports the camera. If you don't need the camera, you just set the camera positions to default and it's fine. It doesn't even need time, as I think, so it doesn't even need the time. It doesn't even need the time. Okay, so we do have a special abstraction for the shader programs, and this thing keeps track of the atlas. That's very, very interesting. That is in fact very, very interesting. So, and it uses atlas for the image uniform. I think we need to rename it to just image, and let's actually quickly go to all of the compilation places and whatnot. So this one is an image and this one is an image. So this code was broken after we renamed atlas to image, but since we never actually used that uniform, it was fine, right? So that's why it basically worked. So, and it doesn't work. Why are you not working? Because I moved them to separate folders, but I never actually updated the paths. Okay. All right. So this one has to be frag, vert, frag. I never documented HSL frag. I think maybe it would make sense to do that. Shader frag HSL. A fragment shader that generates a simple kappa pride animation based on time. Does it even use image? Yeah, it does use image. Based on time. Yeah, okay, so that's fine, I think that's fine. Okay, so let's actually commit whatever we have here. So what we did in here, we just reorganized the shaders, right? So we just reorganized the shaders. Okay. Okay. Reorganize the shaders, right? So I'm gonna push that right into the repo. We're gonna push that right into the repo, mate. Right into the repo. So the next thing I want to do, I want to go to the this thing, right? And when we sync the uniforms with the game, right? When we sync the uniforms with the game, I suppose I want to be able to, for the particular program, I want to be able to set image to something else, right? I'm just thinking, what if I have a separate program for the font? That would be a little bit a waste, a little bit of redundancy, but that will work within our current game engine. Yeah. Okay, so I want to make a small break because I want to make a cup of tea and so on and so forth. And after the break, I'm going to explain what I mean by all of that. Okay, let's make a small break. So I'm going to be back in a snap. Hello. Welcome back. I'm just welcoming myself back. So well, for you, it was probably pretty much instant. So if you take a look at the renderer, right? So the renderer has a bunch of useful functions that we use all the time. Specifically, fill the triangle and like fill AABB, which stands for Axis Aligned Boundary Box, and fill the circle for rendering circles and whatnot. And one of the things you can notice is that they take the program, the shader program. So it's the program that will be applied to the corresponding triangle or AABB or circle when it's actually rendered. So we can try to do the following thing. We can introduce a separate program for the fonts. Okay, let's quickly do that. So I think, I don't remember where it is. Okay, so here it is. We have a special enumerations for all of the programs available in our asset. Right, so we have a regular program, particle program, and pride program. Well, I mean, the pride program is essentially just HSL animation, if you take a look at this thing. Right, you can, if you zoom in a little bit, so it's kind of like meh, but yeah, it's essentially HSL animation. It's kind of funny how this moves in different directions depending on how you flip it, because we flip it by flipping the UVs. I'm not sure if it's a good idea generally, but that's how we do that anyway. So let's introduce something like a font program, right? And the cool thing is that after we introduce this font program, our program will stop compiling. Build sh, because we have a couple of static assert. Yeah, there we go. So we have a special static assert in here, which reminds us that if you updated the enumeration, please also change this code. So maybe we should actually put some sort of a message in here. The amount of shader assets have changed, right? The amount of program assets have changed. Now, if I do something like this, yeah, the amount of, yeah, there we go. So what we need to do in here now, we need to do a program, programs. This one is going to be font program asset. And we're gonna make a program out of two shaders. And I think we're gonna use the same shaders as the regular program. Right, so we're literally going to use the same like combination of shaders, and of course we should also update this thing to 4. Okay, so, but the main difference between the regular program and the font program is going to be that we're going to use different texture units for the image uniform, right? So inside of the program, we are doing what? Yeah, we getting the locations of the image, right? And when we synchronize the uniforms, we actually set the uniforms to the corresponding values. And it's kind of interesting, for some reason, I actually set time twice. I guess maybe I accidentally pressed like a button that duplicates a line and committed it, but since it didn't introduce any bug, I just never noticed it. Okay, so this kind of stuff happens from time to time, so that's totally fine. So maybe one of the things we're going to do in here, when we create a program somehow, is it something like make? Yeah, I think it should be something like this. This is a projectile. What about the program? Yeah, here's the make. Maybe we're also going to provide like a value of the unit. I don't know, maybe that's a good idea to do here. A GL, it has to be in integer, right? So it is going to be integer, like a unit. Okay. And we're going to keep that unit somewhere, probably here, I don't know. Image unit, and let's keep it here. Image unit. There we go. And if I try to recompile this entire stuff, hopefully it will break now in all of the places. And we probably have to set it to self. Image unit, there we go. All right, that's what I'm talking about. So by default, maybe we can set it to 0, because why not, to actually simplify refactoring, because before it was always 0, so it doesn't really matter that much anyway. Okay, so now it works, and in the renderer, I'm gonna set this thing to 1. So now we're gonna use a different unit in there. And when we are synchronizing the uniforms, we're going to be actually setting uImage to image unit, right? It's going to be image unit. There we go. So do we have anything else in here? Seems all right, and everything is compiling. Let's actually try to run this entire thing. Everything seems to be working. Everything seems to be twerking. So we can actually try to test if that works. I'm gonna do something like player. Let me find the player. So it's going to be player CPP. And when we're rendering the player, right, we're rendering the body. Let's actually, instead of Pride program, let's try to use font program, right? And let's see how horrible it will look like. But we of course need to recompile this entire thing. So there's invalid operation on image is sampler. Oh, I see. I accidentally used F when the sampler is in fact is integers. Thank you. Yeah. So this logging, Opengl logging, is actually quite useful. You can enable that logging by just doing something like debug. Yeah, so you have to create a special callback, message callback, and you enable it with GLDebug output and GLDebug message callback. Like a literal lifesaver sometimes, right? It's very, very convenient. So you do something wrong, and yeah, it will warn you about that. It's actually super cool. The Opengl API could have been better, so you won't need this kind of stuff, but yeah. Anyway, so we can clearly see that there is something resembling the font sprite sheet in here. So yeah, I think it is working. So we have two separate textures, and this kind of stuff seems to be working quite well. So let's try to implement enough functionality for our font to actually render things. One of the things I want to be able to do, by the way, is to have some sort of a method. That gives you UV coordinates of the texture, if that makes any sense. So basically, char UV, right? You provide a character, right? You provide a character, and you get a ABB of GL float which is the UV coordinates of that character, right? So, and then you can pass it to the shader, right? And the shader will cut out the character accordingly. So we just need to implement all of that. So let's actually quickly implement this function. So it's going to be font cpp. Font like this. There we go. There we go. This one is going to be just empty. And let me see. What's interesting is that this function doesn't really need to be a method of font because it's going to be operating on compile time constants and stuff like that, but I'm gonna make it a method of font just in case we want to make these parameters customizable. So the first parameter that we want to have in here is probably going to be a texture width and height. Oh, I'm wrong actually. We do have a texture width and height inside of this texture, so we can just use that width and height in here. Okay, that's actually pretty cool. I wonder if we can easily print all of that. So it's going to be font cpp. So when we are loading everything, I'm going to be doing print ln, right? And it's going to be stdio, right? So it's going to be like that. And in here, I'm going to just print stdout result texture. I don't even know what's the size of the texture. I think it's like width and height, right? So it's literally width and height. So this one is going to be width, and this one is going to be height. There we go. This one is going to be height. Cool. And by the way, in the spirit of Rust, maybe I should actually rename this into self, as I did in some other places. Whatever. Right. So let me try to recompile this entire stuff, and I just want to see if we can see the size. I mean, we can't see the sizes. I don't know why I'm doing that, but I'm kind of curious. Right. So here are the sizes, and here is the size of this texture, 128 by 64. But some of the things still need to be hard-coded, right? For instance, the amount of rows and columns, right? The amount of rows and columns. So this one is going to be something like size t rows, right? This is going to be rows, and this is going to be columns. I keep counting this thing over and over again. So maybe I'm going to do that one more time. Let me open it in the Chromium. Right, so this one is going to be amount of rows. 1, 2, 3, 4, 5, 6, 7. 7 rows as usual. Amount of columns is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I think we have 18 columns. All right, that should be enough for us to actually calculate all of these things. And I wonder if we can pre-compute some of the other things. So it's going to be const expr in here. Right, so what other things we can pre-compute in here? For instance, to be fair, we can't really do much, so I don't think it makes sense. Don't think it makes sense. All right, so I'm gonna go to font cpp. Right, I'm gonna go to the font cpp, and we need to find the index of this character in here. Right. First of all, we need to determine if this entire character is even printable. Right. We need to determine that. And so if we take a look at the ASCII table, all right. So the printable characters allocated started from, I think, 32. Yeah, I think they start from 32, so this is a decimal, 32 up until 126. So 32 and 126, there we go. And yeah, this thing is printable. Otherwise, usually what I do in here, I just call this thing with a question mark, right? And one of the things we want to actually confirm in here, maybe at compile time, that question mark is printable thing, right? So otherwise you may go into some sort of like infinite recursion, right? So maybe here we can do something like const expression character invalid, right? So this is going to be invalid, and what we're doing here, we're just doing something like invalid, right? So, and it's kind of a dumb thing to assert, but for some reason I don't want to do that anyway, because who knows, right? So just explicitly say our assumption, because otherwise, if it's not true, if this kind of thing is not true, you go into the infinite recursion. And this function does look recursive, right? It's just like, it's not really recursive in a spirit. It's just like, it calls itself as a fallback, right? But what's, how do you fall back if the fallback is like faulty? You know what I mean, right? It's, anyway, it's kind of a strange situation, but anyway. So the index in here is going to be essentially equal to c minus 32, and there you go, here is the index. So, and now you need to figure out the row and column for your symbol in here, right? So the row, in fact, is going to be basically index divided by amount of columns, right? So yeah, and then column for your character is going to be index mod columns, and there we go, you figure out rows and columns. So after that, I suppose you need to find the position in pixels, right? You need to find the position in pixels. The positions in pixels. To know the position in pixels, you need to know the size of a single character in pixels as well. Right, and the way you can know that is you can essentially take, I don't know how to call this thing yet, but you can essentially take texture, you take the texture width, right, and you divide it by the amount of columns you have, right? That's what you're essentially doing here. You divide it by the amount of columns you have. So this one could be called something like character char width, right? So it's going to be character width. Then you can have a character height. So it's texture height divided by the amount of rows, right? So so this is the index. This is that. This particular thing maybe should be called something like character row and character column. Character row and character column. Right, specific row and specific column. And then we need to start constructing coordinates, right? And specifically in pixels, right? So we're gonna have coordinates in pixels. So let me see how we can do that. So this one is gonna be sort of like a size t. So coordinates is going to be equal to something like this. The position of this thing is essentially vector2 char column char row, right? So that's what it is. And the size is essentially vector2 char width and char height. Not really. You also have to multiply these things like so. And I wonder if it could be expressed in terms of the vector arithmetics. You can have something like size, right, equal to actually something like this. And then position, original position, could be also something like this. We can actually explicitly do it like that. So this is going to be like this. And then maybe your position is going to be multiplied automatically by size, and you can construct ABB out of it. Right. So this is going to be position, this is going to be size, and there we go. Cool. So all of that is also const, of course. It doesn't really have to be modified. doesn't really have to be modified. So here's the size, position, and all of that is actually in pixels, right? So all of that is pixels. So it's going to be size in pixels, right? This is a position in pixels, but this position is actually in rows and columns, in cells. I mean, in cells. That's what I'm trying to say. Like in pixels, right? And in cells. Right. So, and this one is not piece, it's pix. Okay. So maybe I have to actually put like units in here, like for all of them. Pix. So this is character width and height in pixels, right? So it's going to be pix. This is just an index, and this is character row in cells, right? So cell. This one is a size. Yeah, and you can actually have something like position in cells, which is just that, right? Which actually makes this thing obsolete. And yeah, then you construct position in cells by multiplying it by size pixels. Okay, that's actually pretty cool. That is actually pretty cool. And then we have a coordinates in pixels. All right. Can we do something cool in here? Can we do something cool and just basically align like this? Isn't that amazing? Can your Vim do that, by the way? Can you Vim do that? I don't think so. Okay, coordinate pixels. Maybe it would be better to actually do something like equal to AABB. Like, you know, that of course has to be const. Align equal. I don't know. That's what I want. Is it gonna work? Is it gonna work now? Yo. What I'm thinking is, can I just do auto in that particular case then? If it's just that, let's just make auto. Okay, so what's up with that? Expected semicolon. Character width in pixels. Size in pixels. Position in pixels. Size in pixels, coordinate in pixels. Okay, cool. Nice. The thing is, now I need to convert coordinate in pixels to the coordinate in UV. Alright, somehow. I need some sort of a magical function that will do that for me. But this function can only work if you know the width and height of the texture, which we actually do. You know what I'm thinking is that, can we actually replace this thing like this? So this one is going to be texture columns, and this one is going to be texture rows. Can we just do it like this? Alright, we kind of can. It looks ugly, but I mean, we could probably simplify this entire thing if we align it well. Yeah, because we can just do it like that now. So we have a size in pixels. And we can probably bring it in here. So we have an index, we have a position in cells, right? So size in pixels, we take position in cells, multiply by size in pixels, we get position in pixels, then we combine them together and we get coordinates in pixels, right? We get the coordinates in pixels. Though maybe creating coordinates is kind of like too early right now. What we can try to do now, right? So maybe I'm gonna just comment this stuff out. I'm going to create a position in UV because why not? Right, essentially you have a position from 0 to width, right? 0 to width and 0 to height. To get this position in UV coordinates for 0 to 1 to 0 to 1, you just get your position and divide it by the whole width and height. So, oh, this one is actually, so wait, it's a character. Yeah, okay, I'm just thinking about the different namings. So what we can have in here is basically texture size, right? So this is going to be just a texture size, and what I'm doing in here, I'm taking texture width and texture height, right? Texture width and texture height. And I kind of want to, I don't know why, but I feel like I want to make it pretty. So I kind of want to make it pretty and express everything in the vector coordinates. That's what I want to kind of make, but yeah. Maybe I need to make a small break, just a second. All right, I'm back. So what we have in here is a texture. Let's actually put it like texture size in pixels, right? So this is a texture size in pixels. Then we can also have something like texture size in cells, right? And it's essentially vector2 calls and rows, right? And what we can do in here, we can have a character size in pixels by taking, look, texture size in pixels and dividing it by a texture size in cells, right? So that's how we can do that. So here is the texture size in cells, columns and rows, and then in pixels, width and height, we take it in pixels and divide it by cells, and we get a single character size in pixels, right? It's a single character size. So after that, we can have a character position in cells, right? We have a character position in cells, and we know a character size in pixels. So to construct a character position in pixels, we take a character position in cells and multiply it by a character size in pixels, and that's how we convert over all of that. This is how we convert all of that. So I really wanted to express all of that in terms of the vector operations. I think it's kind of cool. So align regular expression like this. So yeah. So this one could be actually called a character index in that case, right? So it's just a character index. So character index, and let me reassign all of that. All right, texture size, texture position, and now we need to have a character position in UV, right? So we do have a character position in pixels, right? And that means it's a value from 0 to width and 0 to height. We need to map it to a value from 0 to 1 to 0 to 1, and you can easily do that by dividing it by a texture size in pixels. There we go. So that's precisely why I wanted to express all that in the vector coordinates, because it just makes the code a little bit more compressed and a little bit more readable, right? And we can do a similar thing, I suppose, to the character size in UV, right? So you can essentially simply take a character size in pixels, right? You take it in pixels and divide it by a texture size in pixels, and there we go, you have a UV. After that, your final result is going to be simply AABB, character position UV, character size UV. There we go. So some of these things may not work because I don't think we have a division implemented for the vectors, but it shouldn't be that difficult to implement at the end of the day. So in here, by the way, I don't think this kind of stuff is needed. You can actually put like a faulty branch like the last one, and this one seems okay. This one seems okay. This is not needed anymore. And yeah, there we go. We managed to implement this entire thing. I think we managed to implement this entire thing. Let's see how miserably it will fail when we try to compile it. All right, so we don't have a division for long unsigned int. Okay, so this one seems to be an integer, right? This one seems to be an integer, but maybe what I need to do, I just need to cast it to size t. Right, I think that's the easiest thing to do in here. Let's just cast it to size t. All right, so long unsigned int. Oh, you still don't have it. Okay, so we don't have a division operation for these things at all. So we need to go to the LA. It's a Geo. Did I rename it to LA? Did I rename it to math? Yeah. Okay, so do we have an operator plus? Okay. For these things, we have operator multiply. Okay. And I suppose we need to have an operator divide. So you can only divide this thing by a scalar, and let's define a thing that allows you to divide a vector by another vector component wise. Right, so it's going to be operator like this: v2ta, v2tb, right, and we're going to just return v2t, ax divided by bx, ay divided by by. There we go. Should be able to do this kind of stuff now. Let me see if it's gonna work now. Yo. Oh yeah, okay. This one is interesting. I completely screwed it up. Right, so I forgot that these things in pixels are integers, but UV coordinates has to be in floats. So what we need to do in here, we need to cast both of them to GL float. Right, thank you so much, C++. Very cool. Cast to GL float. Right, so we're casting all of that like this. Cast to GL float, and this one is going to be cast to GL float. Yes. Kawaii fucking desu. Is it compiling? Motherfucking compiling! Noise. Alrighty. Cool. So we have this kind of stuff. I wonder if it's gonna work. And also, it's quite important is that it's gonna be inverted, right? All of that is gonna be inverted. But I suppose with AABB, I think we have a function that flips this kind of stuff. Right, so do you have flip? It's a math HPP flip vertically, horizontally. Yeah, okay, so it's definitely going to be flipped vertically, right? Because the actual coordinates go from 0 width, 0 height, but we need to map it from 0, 1, 0, 1, right? We need to flip it vertically. So one of the things in here we can do for the UV coordinates in the font is just like we constructed this entire thing, and let's just flip it horizontally. There we go. We constructed this thing and flip it horizontally. Beautiful. Beautiful. All right, so what do we got? Q. To be fair, it would be kind of cool to do that all on the shader. Yeah, it would be super cool to do that in the shader. I just realized that. And I think I already done that before. Yeah. So I made a game some time ago for WebGL and whatnot, right? That looks like this, and as you can see, it supports text and with it like a similar font. And I think I actually coded it so all of this math is done on a shader. It would be super cool to have it like that in the C++ game as well. I'm gonna put the link to this game in the description if you're interested in this thing. So my WebGL game. Alright, so of course you can work with it over HTTPS. I know it's 2021. It does work over HTTPS. I don't know why it doesn't redirect me. Maybe because I need to force HTTPS. Just a second. I think that's precisely what I need to do. So I'm going to go to the settings and then pages, force HTTPS. Okay, let's actually force HTTPS. So now it will automatically redirect to HTTPS. And because of that, I'm going to actually give you the link with HTTP. So you can check if it actually redirects to HTTPS. Anyway, okay. Font char UV should be implemented entirely in a shader. So we're gonna have a to do in here. I don't want to work on it right now, maybe a little bit later. Right, so we also flip it horizontally and everything seems to be okay. Everything seems to be okay. All right. So how we're gonna actually render the text in here? What I'm thinking is that maybe we're gonna have a method called render, right? And it's going to accept the renderer, believe it or not. Right, it's gonna accept the renderer, and maybe the text that you want to render, right? Maybe some sort of a text that you want to render at a particular position. Let's actually implement something like render character, right? It's going to accept a single character. Let's actually do the text. Go. So it's going to be text, and what else do we want to accept in there? We want to accept the position, right? So where is it going to be located? Position, and maybe also a color. Let's also supply the color. Do we need anything else in here? I don't think so. This one is const, of course. This one is const. Nothing needs to be modified in here. So we render the text with the renderer at a particular position. And the way we're going to do that, we're going to actually supply a corresponding program. So everything should be okay. Let's quickly implement this entire thing. So this is going to be font. All right. And how are we going to be doing all that? I'm going to render only a single character in here. So maybe, I don't know what would be easier to actually render in here. Let's actually iterate starting from 0 up until the length. So it's going to be strlen text. All right, so it's going to be something like this. And yeah, I'm going to be iterating through all of that. And I'm going to be rendering everything in a single place. So position. So what we need in here, in fact, we need to go to the renderer and fill AABB. Right, let's fill AABB. So this is going to be a renderer. We'll fill in AABB. So where are we going to render all of that? I don't know. We can render it. Well, I mean, we do have position. I forgot that we have a position. And if it's AABB position, let's set the size to 100, right? So, but the actual size should be proportional to the ratio of the character, but I don't really care about it right now. Right. So the shade is essentially the color, right? So this is the color, and UVAABB is going to be char UV text I, and the program that we're going to be using, the font program asset. There we go. That should be it, believe it or not. Yeah, so just fill the ABB, provide the position and stuff like that, and it just should work. Should just work. Okay, then. Let's try to recompile this entire thing. And font char UV, it has to be const. It has to be const. So this is something to do with double, I'm pretty sure. Okay. Alrighty. Okay, so let me actually go back to the player and get rid of this font. So we're going to use a regular program, right? The regular program asset. And now, yeah, so the player is totally fine. We can try to render some text on top of the player, right? So some player text. But the question is where we're gonna render all of that. Let's go to the game. Let's take the font, right? Here's the font, and let's render text, right? So we have to provide the renderer, right? So we do have the renderer, and we're gonna print E, right? We're gonna be printing E at the position of the player. Does the player have a hit? Yeah, okay, so this is how we extract all of that. So we have a body has a hitbox. All right, body had a hitbox, and we take the position and the color. So do we have RGBA like red or something? Because I want to render all of that in red. Yeah, we do. Okay, so that's fine. So let's try to render E, a single E. So maybe after that we may want to exit this entire function just to like not render anything else because it can obscure this text. So let's actually try to run this entire thing, and it actually has to be called pause if I remember correctly. Yeah, well, doesn't look like E, it looks more like 4. Nice one. Nice one. By the way, we could have actually used like a hitbox of the probably yeah. Why is this 4? Excuse me. That is so weird. Doesn't make any sense. Is that because we're flipping it? We can try to, and 4 is also like flipped. Because I have to flip it vertically instead of, okay, that makes sense. I'm an idiot. Okay, flip vertically, right? You have to flip it vertically, and let's try to rerun it, and it should be 4 now. Yeah, it should be 4. Well, I mean, it shouldn't be 4, but I mean, in terms of the orientation, it should look like this. In terms of orientation, it should look like this. So. Okay. So let me see. We do C32. Is that because we confuse columns? All right. Yeah, that's precisely why. Because, yeah, we confuse columns and rows. Now we're talking. How about it? Isn't that cool? I think it's goddamn cool. That is very, very cool. So, but you can notice that we have a couple of problems in here, right? We have a couple of problems in here. First of all, is the ratio, right? So, ratio is fucked up. Second of all, no transparency. And another one is that everything is blurry, right? So these are the problems that we have here. Did I spell transparency correctly? I'm pretty sure I didn't spell it correctly. I spelled it correctly first try. Would you look at that? So the edges of the font should be actually very, very sharp, and the black color should be the transparent color. So all of that could be easily like fixed, at least. Let me see. Let me think. We can fix on a shader the transparency, right? So essentially, we need a special font shader. That's what we need in here. A special font shader. Ratio can be fixed in the C code, and blurry can be fixed by changing the parameters of the texture, right? All that can be fixed, changing parameters of the texture. So let me quickly do something like this. So which one should we tackle first? Let's actually start with ratio. This one is relatively simple, I think. So right now we just use this stupid ratio. To use a different one, to be fair, we need to keep track of the character size in pixels, right? So we keep recalculating character size in pixels over and over again. So maybe we should sort of cache it, if you know what I mean. We can try to cache it. So I'm gonna do font C HPP, right? And I'm gonna move font size, maybe also font size cells. Do we even use font size cell anywhere? We only use it to calculate character size in pixels. Right, so let's keep the following thing. We're gonna keep vector2 size t, character size in pixels. So this thing is gonna be cached from now on. So, and how we're gonna cache it? We're gonna actually calculate it in here, right? I'm gonna calculate it in here because the size of the texture itself doesn't really change very often. To be fair, a lot of these things could be actually cached. All of these things could be actually cached. All right, so what do we have in here? Okay, texture size in pixels. All right, texture size in pixels. Let's also move it in here. I think it's worth moving texture size pixel, yeah, because we keep reusing it, so it does make sense to sort of keep it. Okay, so this is gonna be self, texture size in pixel, texture size in cells. Do we use texture size in cells anywhere? No, we actually don't. So that means we can only like put it in here and just forget about it. Yeah, because it's never actually needed. So an alignment actually looks kind of lame. Okay, texture position in cells, texture position in pixels, and position size. This is size UV, and size UV can be also cached, as far as I can tell. I'm pretty sure it can be also cached, so let's actually quickly cache all of that. So self UV and character size, texture size, all of that could be pre-cached. Size in pixels. So yeah, all of that can be simplified now. Interestingly here, yeah, maybe we can simplify that a little bit later. Anyway, so let's actually try to compile that. What do we have? Texture size in pixels. Yeah, now let's actually put them in here. Texture size in pixels is going to be something like v2 size t. Texture size in pixels. There we go. What else do we have in here? Oh, this one has to be self. Yes, yes, yes. Texture size in pixels. Okay, self. Oh, now all of that has to be like this. God damn. I mean, it's fine. It's almost like I'm programming in Python. It almost feels like I'm programming in Python. Text size cell. Text. But we don't even use it anywhere, right? Oh, yeah. That's why it's an intermediate value. That is why it is an intermediate value. And this one is in UV, and that's quite important. All right, so this one is going to be character size in UV, is going to be GL float. Right, this is a GL float. All right. Is it working? Is it working? Cool. So we have a character size in UV. So, and essentially, on top of position, I think we also should provide some sort of a scale, right? So it's going to be scale. And this is the scale that we're going to use in here. So I'm going to be just taking the character size UV, right? Character size UV and multiply it by a scale, right? And let's see if it's going to work now. So it is not working that well because we need to update the signature in here. So scale goes somewhere here. So we have to provide scale in here. So let's actually provide it like 100. Why not? You know what's cool? It's there. But it just didn't work. Because we are in the world coordinates. Okay, world coordinates are actually kind of like big coordinates. Even if you like... Oh, right, and it's completely fucked up. I wonder why though. Maybe because we need to actually use it in pixels. Let's actually use it in pixels because that... Yeah, because we're using pixels when we're talking about these things. Yeah. So it has to be characterized in pixels, but unfortunately you have to cast all of that to GL float first. Otherwise it's not going to really work well. Right. But now that's a big E. That's a pretty big E. So let's actually make it 10. All right, I think ratio now is correct, more or less. I'm more or less happy with the ratio. So I'm gonna go in here and I'm gonna mark it as this one. So transparency is a little bit involved. So I'm gonna put it down below. Blurry should be relatively easy to fix. It's basically a matter of choosing a different filter. Right, so instead of linear, right, you have to put nearest, I think. And that may break some things. I don't remember what you have to do in there, but yeah, now every like the E is actually has sharp edges, but other textures now also have sharp edges. So yeah, Atlas has to have linear interpolation, but our font should have nearest interpolation. So we need to distinguish between them. So one thing I'm gonna do for now, I'm gonna just introduce a flag, doing something like boolean pixelated, or maybe nearest, and by default it's gonna be false, right? So if nearest, right, I'm gonna put it like that. Otherwise, we're gonna use linear. So it is a hack, but it's like a super quick hack. Linear, right? Super quick hack, and hopefully a little bit later we're gonna do something about that. All right. So this one, I think you have to put the default parameter in the in here when you construct the texture like this. So this one is going to be nearest, and by default it's going to be false, right? And it's going to become blurry yet again, right? It becomes blurry yet again. But now specifically for font, when you construct the font, right, and you convert, yeah, when you create this texture, you're going to set it to true, right, and it become sharp again. So everything is going to be blurry, but specifically E is going to be sharp. Okay, so we've fixed 2 problems out of 3, right? So we fixed the ratio, we fixed the blurriness, and now we need to introduce transparency. But for the transparency, oh boy. Oh boy. There are 2 ways to maybe introduce transparency. We can do that on a CPU once, or we can do that on a shader. So one thing we can do, I'm gonna go to the font, right? So we loaded the texture, right? And we can iterate through the pixels and stuff. So it's gonna be y0, y less self-texture height plus y, right, and we're gonna just put this thing like this, right? This one is gonna become x width x, and then it's gonna be self-texture pixels, I think, is gonna be y multiplied by self-texture width plus x, and I don't know how to better deal with that, so let me go to the texture. So what do we have? It's RGBA 32. Okay, so this is RGBA, this is a single pixel, and maybe I'm going to treat it as a pointer, right? So this is going to be as a pointer. If pixel is completely equal to 0, right? If this entire thing completely equal to 0, I'm going to... it has to be equal to black, so... I don't remember how black is. I think it's going to be 0, 0, 0, 0, 0, 0, FF. I think but if it's RGBA, so it means it has to be 0, 0, 0, but FF should be somewhere here. We can always easily check that. If it's that, I'm gonna always set it to 0, like this. Right, so this is one way we can sort of like hard code that on a CPU. It's gonna be done once on a CPU during construction, and it's not gonna happen on each frame, so it's not that expensive. But that will enable us to reuse existing shaders without creating new shaders and whatnot. So what's that? Comparison. So maybe this thing has to be int then. Sure, I can make it int if you want me to. So what else do we have in here? This has to be a pointer. Sure. Let's make it a pointer. Anything else, Mr. Compiler? Okay, so did it work? I can't see if it worked or not. Maybe we can change the background. I feel like it did work. Okay, I feel like it did work. Do we have a way to change the background in here? We don't. That's actually very interesting. So we don't have a way to change the background color. All right, where do we set the background color? Gel clear color. So we have a background color in here, and the background color is defined somewhere. Let me see, where is it defined? Okay, so we could have just moved it to vars, right? So let's quickly do that. Background color, and it's going to be literally a color, and that color is just this. There we go. And I can remove this entire thing now. So this is a background color. So that will require recompiling the like everything, but that's what we do anyway. There we go. So now we should be able to actually modify the background color in runtime. For instance, I can give it a little bit of a red tint. So yeah. Or maybe even blue tint, so maybe even like that. So and we can clearly see that E is transparent. So it is in fact very much transparent. I really like that. Okay, so I did guess everything correctly. So, and did we fix all the problems with this thing? I think we did. So we have we fixed ratio, blurriness, and transparency. Okay, cool. So maybe the time has come to commit all of that stuff. So we have a texture. So what essentially we did in here? We actually implemented this thing only for a single character, but one of the things we probably want to do is render a sequence of characters, right? So that means we'll have to update the position like this. So it's going to be vector 2i 0, but also this thing has to be, well, so we can take a single character size in pixels, right? So this is a character size in pixels, and we're going to only get the X, but we're not going to get Y. Maybe the easiest way to do that is actually take like this character size in pixels multiplied by this entire thing, right? Multiplied by this entire thing. You know what? We can also multiply it by I. That's cool. That's pretty cool. And after that, we can cast all of that to gel float. That's right. Okay, that's actually cool. I really like that. So yeah, that's pretty poke. We can character size in pixels multiplied by I, and yeah, that seems to be working. All right. So now, if I wanna render more characters in here, so ABC, will we be able to see that? I don't think so. So what's up with that? Class deduction couldn't something. Maybe I have to do it like size T then. I don't know why it couldn't use the thing. But now it is fine, and it didn't work. Yay! Yay! I'm so happy it didn't work. Probably because it doesn't take the scale into account. Okay. That, I think, makes sense. We can actually put the scale in here, and what's funny is that we multiplied by scale. Okay, so maybe it doesn't require to be like that. Right. And we have ABC. Yes. Can we actually put something bigger in here? Yes, it is working. It is seem to be tough. All right, so we know how to render text now. We have an ability to render texts, but we can only render them inside of the world. So we need that is actually pretty cool. So we have a bug that if you kill the enemies very fast, it's, yeah. I don't know how I did that. Yeah. But it actually spawned them twice, but that was a really interesting bug. Okay, I don't even know how to reproduce that, but maybe. Cool. So we have an ability to draw the fonts and shit. Okay. So what did we do in here? Introduce font entity, implement text rendering inside of the world, right? Inside of the world. And I'm going to push that right into the repo. Okay, so I want to make a small break, and after the break I want to think how to render things on the screen, right? How can we render things on the screen? And maybe we can do something pretty, I don't know. We can at least solve the problem that solves the issue, right? That we need to somehow indicate that the the reloading of the configurations has failed. Actually, by the way, the easiest way to render on the screen right now is just to render relative to the camera position. Right. When you're rendering something, right, you can query the camera position and just subtract or add like the camera position accordingly or something. You can do something like that. Yeah, I guess you can do things like that. But anyway, so yeah, let's make a small break, and after the break we can think about all that. So let's see what it takes to render the text on the screen. It's going to be very interesting. So right now we can quite easily just render it inside of the world. Right. So here's the player's body and whatnot. And if I take the body hitbox, right, we can actually take a player hitbox because it stretches and stuff like that. So it's going to be actually very interesting when it tries to jump and whatnot. So, and we're going to take this entire stuff, right? This one is going to be a game render text player. The position is going to be player hitbox. This one is going to be actually very interesting because the position is left bottom, right, left bottom, and we render it also at left bottom. But what we want to do in fact is take the player hitbox position, right, so and add player hitbox size, but ignoring X, I think. So it's going to be something like that, ignoring X. So we're only going to take the Y. So I think that's precisely what I want in here. So the scale here is going to be like around 10. Right, and the color, let's say that is going to be red. All right, because why not? Why not? And let's see if it's going to do the trick. Okay, so it has to be a part of the font. Sure. Anything else you want from me? Yeah, there we go. So, and you know what's cool is that the the thing is moving. The thing is moving as the player stretches. I think it's like it's a very subtle thing, but I think it's pretty cool. I think it's pretty cool. So yeah, we can render it inside of the world, but what does it take to render it on the screen? So well, the hackiest and easiest way to do that would be, all right. When you're rendering things, right, maybe we're gonna render everything like on top, right? When you're rendering, the position is essentially camera. You take the position of the camera position, and yeah, so it's essentially going to be following the camera position, but it doesn't take into account the camera size, so it might not be actually very accurate. And this one is probably called pose, if I remember correctly. I'm not 100% sure, but we can, yeah, okay. Oh, that's actually pretty interesting. So it scales with the game, but apart from that, it is kind of like on the screen. So essentially it's following the camera. That makes any sense. All right. So what I'm thinking is that I need some sort of a good thumbnail, right? That's what I need. I need a good thumbnail. So I need to generate some pretty pictures. So let me actually take this color and pull it into the configuration. So it's going to be text color. All right, text color assets vars, and let's put it somewhere here. Text color. Initially, it's going to be just red, 0000FF, and then we'll be able to customize that color. So I need to like find maybe complementary colors, if you know what I mean. Some sort of a complementary colors. So let me go in here. So what's going to be the background? Let's make it even brighter so we can clearly see. That's actually a pretty good color. I really like this color. I think I liked it when it was like 50. So speaking of the text now, I think maybe I'm gonna actually keep it like around this. Did it make it a little bit more faint? Maybe it did, maybe it didn't. We'll see. So AA. We need something contrasting with the blue, and as far as I know, it's something like yellow, orangish. Yeah, something yellowish, orangish. So that means it has to be like FF, BB. Yeah. Okay. So on the player, it's actually not really that contrasting, I would say. So maybe we can disable the player actually. So let's actually not render the player whatsoever. That will require to actually change this entire thing. All right, so here is that, and maybe even something like that. Yeah, I think I like what I'm seeing in here. And we can just do something like this. Where is the player? And let's actually replace it with your mom. Right. Let's actually replace it with your mom. And let me see. Yeah, something around like that could be a pretty good thumbnail, I think. More or less. Maybe not. I'm not a YouTuber, you know, I'm a Twitch streamer, but I'm gonna try this as a thumbnail and we'll see if it will work out or not, because yeah. Okay, so we do have now mechanisms for rendering the text, and I think I'm gonna make a pull request. So we're gonna do this stuff, and yeah. So let's make a pull request. Text support. Okay. So let's see if it builds on like all of the supported platforms. So the amount of changes wasn't that big, which is good. I like a small amount of changes. I like that you can make a small amount of changes and actually add a feature and whatnot. So I think it's good. I think I also introduced a couple of to-dos that I want to snitch up. Snitch report prepend body introduced in 88, and let's see. So yeah, this one is not going to be that. And yeah, I think we did everything. So let me push it one more time. One more time. We gonna celebrate. I'm a little bit hungry right now. Why am I so hungry? Alright, anyway, I think today was a pretty productive stream. Not gonna lie. We managed to implement the text support, and now we're capable of rendering text in our game. So I'm gonna call it a day then. I'm gonna call it a success. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you tomorrow. Tomorrow we're gonna continue doing this thing. We're doing game development for the entire weekend. So I will see what we can do tomorrow. Maybe we're gonna start using the text support for something, for example, for indicating the errors or some in-game messages and stuff like that. And yeah, that's it for today. Nothing much to say. I hope this stream was interesting and educational. Thanks everyone for watching. Love you all.